Fourth graders, what's going on? It is time for another earth erosion deposition investigation, but we're gonna introduce a new variable. We're gonna introduce the idea of slope, and we're gonna try to figure out how slope affects erosion and deposition. All right, and what do I mean by slope? Mr. Bergen, what is slope, right? So all we did is I have two trays here. Look at tray one, tray two, but if you look at one is higher than the other, all right? I made it higher, I propped it up to increase a slope, so it's at an angle, so it's angled down. So the question we're trying to figure out today is how does slope affect the rate of erosion and deposition? So I want you to make a prediction, which is how do you think increasing the slope of the tray will affect erosion or deposition? Now you could be like, I predict or I think that increasing the slope will ... All right, so right now it's time to take out our worksheets. Okay, so we're gonna copy again our model into our worksheet because we want to track our data. So go ahead and draw this rectangle. Remember this gray shaded darker area represents where the sand started. The sand is 20 centimeters from the top of the tray. So go ahead and draw this. You can draw the ruler and the cup sits on top of the ruler. And then remember we have to put the rest of the centimeter markers, 25, 30, all the way to 50, because we're going to eventually draw and indicate where the sand, the earth material eroded and was deposited or deposition. All right, and then we're going to do another one, and right, because one of them is sloped, where there's an incline. So this one will be titled slope tray. Same setup. Rectangle, draw, make it darker where the sand started, indicate the centimeter markers so you can track your data how far earth materials eroded in this one. All right, so everything is the same. There's only one difference. They have the same amount of sand, and I'm going to pour about the same amount of water. The only thing that's different is that one of the trays is sloped. There's an incline or decline. All right, so this is what we're gonna do. I'm gonna flip this around. I am going to pour the water, and we're gonna see what happens when I pour water into the flat tray, into the slope tray. But I want you to notice, pay attention to what you notice. Does the erosion happen faster? Does it happen slower? Does it erode and is it deposited farther? And so these are the things we're going to look for because we are going to compare and contrast the flat tray, and the slope tray. All right, so this is what I'm going to do. I'm going to have to put this down. Let's see if I can do this right here. All right. No, I can't do this. All right, so here we go. Slope and regular. Let's observe. What do we notice? All right. Again, this one is sloped. This one is flat. Yeah. Whoa. What do you notice about this one and how it's moving? How is the water flowing? Pay attention to the water movement. All right. Notice the deposition. Is there any erosion going on? Is there erosion happening faster in one of them, slower in one of them? All right, look at water is already at the bottom of the sloped one, whereas water hasn't reached the bottom of our flat one. What do you notice as far as canyons and valleys? Do you notice a difference in the canyons and valleys? In the alluvial fans? All right, look at. We are just now getting to the bottom. Well, this one, whew, it is pouring into our bucket. All right, so we're noticing the difference between the sloped and the non-sloped, the flat, and how it erodes, the rate at which the land erodes. All right, we're looking at the canyons and the valleys. All right. Look at, we have erosion all the way down at the bottom of this tray, whereas in the flat one, we only really have erosion, right? It's coming here, there's clay that's falling, but look at the sand has traveled farther. And we know that sand is heavier, so there has to be a reason why even the heavy sand and earth particles are farther down in the sloped, whereas in the flat tray, the sand, the heavier particles haven't traveled as far down. Maybe a bird's eye view top. Okay, do you notice any different with the erosion in the slope versus the erosion in the flat? All right. So basically we're out of water now. So let's think. Where did the erosion occur? Did the slope make a difference in how much earth material eroded? What did you notice? Was there a difference? Did you notice in the time that it took for the erosion and the deposition to take place? Did erosion and deposition take place faster in the slope or the flat one? Or was the erosion and deposition at the same amount of time? Did the slope affect the shape of the canyon that was formed after? Right, let's look at the shape of the canyon. So this is the irregular one. So we have our canyon here, and then our sloped. Slope, flat. Is there a difference in the shape between the flat and the sloped canyons? Why do you think that there was more erosion in the sloped tray? Go ahead and think about that. We're going to keep discussing this in class. But yes, so we should be drawing in our journals the differences. I will post a picture so we can track the erosion and deposition. But here we go. Good job.